Okay, in Geometry 10.4, we're going to talk about angle relationships and circles. So there's three different scenarios. If the angle is at the center, called the central angle, that's this angle right here. We already talked about this. If that's the case, then whatever that angle is, it equals the measure of the intercepted arc. So angle A right here equals the measure of arc BC. The second scenario is if the vertex of the angle is on the circle, anywhere on the circle. Now, if it's on the circle, then you have to double the angle, and that equals the measure of the intercepted arc. So you do 2 times angle A, this angle right here, and that equals arc BC. A different scenario that you haven't seen yet is this scenario right here. This vertex of this angle is still on the circle. It's lying on the circle. Here are the sides of that angle. So because it lies on the circle, it still follows the same rule. 2 times that angle equals the measure of the intercepted arc. And so 2 times angle A, or if I wanted to be more specific, angle DAB, that's this angle here, 2 times that angle equals the measure of arc AB. The third scenario is if the vertex of the angle is outside the circle, such as right here. We're still going to double it, so you're still going to multiply it by 2, but now you have 2 intercepted arcs. You have an inside intercepted arc, which is this arc here, and you have the outside intercepted arc, which is this arc right here. And so what you have to do is you have to double the angle, so 2 times the angle plus the inside arc equals the outside arc. So 2 times the angle plus the inside arc equals the outside arc. Okay, so on your notes and homework, we're going to go over several problems in here. And I put some little clip notes at the top. If the vertex is on the circle, then 2 times the vertex angle equals the intercepted arc. If it's outside the circle, then it's 2 times the vertex angle plus the minor arc, which is the inside arc, equals the major arc, which is the outside arc. And remember that if you add the minor arc and the major arc, if you add all the way around, it equals 360 degrees. If you go full circle, that equals 360 degrees. So let's look at number 1. It says, find the measure of the arc or angle indicated. So in this problem, I see that my question mark is right here, so I will call that X. Now, this vertex is on the circle, so you have to double the angle, and it equals the intercepted arc. So it would be 2 times 75 equals X. Well, 2 times 75 is 150 equals X. So X is 150 degrees. So the measure of this arc here is 150 degrees. Let's look at number 2. So here, our question mark is this angle. This angle is our question mark. So I know that because the vertex is on the circle, I have to do 2 times the angle. So I know I'm going to be doing 2x equals the measure of the intercepted arc. Well, here's the intercepted arc. Well, we need to figure out what that is. Well, I know that the distance all the way around that circle is 360. So if I need to find this piece right here, I would say 360 minus that, because the rest of the way is 214. So 360 minus 214 is 146. So this right here is 146 degrees. So for my equation, I have 2x equals 146. We'll solve for x. We'll divide by 2, and x equals 73 degrees. So that angle is 73 degrees. Let's look at number 3. Now we have to solve for x. And so I know that this angle here is 46 degrees. which means if I want to know what the measure of this arc is, all I have to do is multiply that by 2. So 2 times 46 degrees is 92 degrees. So now when I look at this, if I add up the distance all the way around, I have 2x plus 4 plus 92 degrees. All of that goes full circle, so it equals 360. So we combine our like terms. 2x plus 96 equals 360. Subtract 96, that. 2x equals, oh, I'm sorry, it's 22x. 22x equals 264. And then we divide by 22. And x equals 12. Let's move to number 5 now. Now we have to find the measure of arc DC. Well, regardless, we have to solve for x. So the first thing you have to do in every single problem is solve for x. And so if I double the vertex is on the circle, so if I double this, it has to equal this. So I say 2 times 2x plus 45 equals 2x plus 90. We're going to distribute the 2. You have 4x plus 90 equals 2x plus 90. Let's get our terms together. So subtract 90 to get rid of that. Subtract 2x to get rid of that. We get 2x equals 0. Divide by 2. And x equals 0. Now I'll go back and see what I'm trying to find. I'm trying to find the measure of arc DC. Well, arc DC is this arc right here, which is represented by 2x plus 90. So arc DC is 2x plus 90. Now we know that x is 0. So that equals 90 degrees. All right, now let's go to number 7. So number 7 has the vertex outside the circle. So I know I have to multiply the angle times 2, and then I have to add this arc here, and that is going to equal this arc here. Well, let's identify our question mark. We'll call that x. Now, if I'm going to call this arc x, that means I have to find a label for this other piece, because they didn't tell me what that was. Well, I know the distance all the way around the circle is 360. So I can label arc QS as 360 minus x. And so now I have enough information to say 2 times this plus 360 minus x equals x. So 2 times 55 plus 360 minus x equals our outside arc, which is just x. So that's 110 plus 360 minus x equals x. This is 470 minus x equals x. Bring that over there, so you'll add x to get rid of it. 2x equals 470. Divide by 2, and x equals 235. And that's degrees, the measure of that arc. Alright, let's look at number 9. Again, we have to solve for x. We have to have a value for all 3 parts. The angle, the inside arc, and the outside arc. They gave us the angle, 6x plus 5. They gave us the outside arc, 23x plus 5. What we need is a value we need to name the inside arc. Well, just like that other problem, we said this piece is 360 minus that. And so let's name that. So 360 minus 23x plus 5. This is why it's important to put 23x plus 5 in parentheses so that you get that correct. So now it's like distributing a negative. So that's 360 minus 23x minus 5 If I combine these, I get 355 minus 23x. So our our inside arc is 355 minus 23x. So that is what I'm going to use in my equation. So I have 2 times the angle plus 355 minus 23x equals 23x plus 5. So let's do that over here. So 2 times 6x minus 5 plus the inside arc, which we named 355 minus 23x equals the outside arc, which is 23x plus 5. Okay, so we'll distribute this. So we get 12x minus 10 plus 355 minus 23x equals 23x plus 5. We'll combine all our like terms, and we get negative 11x plus 345 equals 23x plus 5. Add 11x to cancel this. Let me write that more clearly. We will subtract 5 to get rid of that. And now we have 340 equals 34x. 5 by 34. And x equals 10. And to go back up, that's all we wanted to do was solve for x. Lastly, with number 19, I have a measure for the angle, so I know I'm going to have to multiply that by 2 because the vertex is outside the circle, plus the inside arc, which is 91x plus 1, equals the outside arc, which is 213x minus 1. And so let's write that equation. I didn't have to label anything myself. I didn't have to name anything, page me everything. So 2 times 60 plus the inside arc, which is 91x plus 1, equals the outside arc, which is 213x minus 1. So 120 plus 91x plus 1 equals 213x minus 1. So 91x plus 121 equals 213x minus 1. Subtract 91x to get that over there. Add 1 to get rid of that. And 122 equals 122x. Divide by 122. And x equals 1. Now let me go back up. They wanted me to find the measure of arc JL. JL is from J to L. That's represented by 91x plus 1. So arc JL is 91x plus 1, which is 91 times, well now we know that x is 1, plus 1, which is 92 degrees. I'm not going to do any more examples, but I just want to show you this on number 21. You need to be careful. If it's asking you for the measure of arc URT, URT goes from U to R. Now we know that's 190, and then to T, which is this. So once you know what X is, to find this, it's going to be 190 plus 26x plus 2. So just be careful with that one, that you're finding the correct measure of the correct arc.